On the SAT, you're going to get a lot of questions with variables in the answer choices. And a great strategy for you to use, especially when you have no idea how to do the problem algebraically, is to choose numbers. So we're on page 787. This is number 9, and let's read it. It says, how many seconds are there in m minutes and s seconds? All right, so I said all we can do is choose numbers, right? So let's choose numbers for our variables. Why don't we make m 1? We'll make it really easy on ourselves. And we'll make s 10. So all I'm going to do now is I'm going to read it back. How many seconds are there in 1 minute and 10 seconds? Okay? And we all know that 1 minute has 60 seconds, so we can write that. So this is 60 seconds plus 10 seconds. We get a grand total of 70 seconds. Okay, so now we have our final answer, right? We got 70 seconds. This is what I call our magic number. So once you get this number, you have to find that number in the answer choices. All right, so we have to plug in what we picked for M and S into our answer choices. So now let's go and test our answers. I can start with A here. So it says 60M plus S. All right, so what did I say M was? Well, I said M was 1, right? So that's 60 times 1, or 60. What did I say S was? I said S was 10. So I'm just plugging back in. And what do you know? We got a little lucky here. We got it on the first try, right? 70. We were looking for 70. So your answer is choice A. Alright, so this is a great strategy, especially when you have all these variables in your answer choices. You can choose numbers. Another great strategy to use on test day is working backwards. We're on page 651, this is number 4, and I chose this problem because it really is a prime example of when this strategy works well. Let's take a look. It says the numerator of a certain fraction is 5 less than the denominator. If the fraction is equal to 3/4, what is the denominator of this fraction? So let's say you got to this and you had no idea how to do this, you couldn't do it algebraically. Well, this is how you work backwards. You can assume that choice C is correct. Now we just got to be aware, what are we saying when we pick choice C? It says, what is the denominator of the fraction? So we're assuming that the denominator is 16. And it says the numerator of the fraction is 5 less. So what's 5 less than 16? 11, right? So does 11/16 equal 3/4? And if it's not readily apparent, you can go back and punch it into your calculator real quick, but you'll very quickly find out that 11/16 does not equal 3/4. So this is wrong. Choice C is not correct. It's at this point when you got to figure out, should I be going smaller? Should I be going, should I be going to the bigger choices? It's a little hard to tell in this problem, so I'm going to cheat a little bit. I'm just going to assume we go to D next, and that's the right answer, but after you try a few of them, you'll eventually get to D. And let's see what happens when we pick choice D. Well, we're assuming D is correct, so the denominator of the fraction equals 20. What's the numerator? 5 less. So that's 15. Does 15/20 equal 3/4? Okay, and if you can't see it right away, you could always plug into the calculator, but yes, 15/20 does equal 3/4. So your answer is choice D. So working backwards works really well when you have nice, easy answer choices, not variables. And keep in mind that you're just going to go back, you're going to pick an answer and work it back into the problem. So this works for the easy ones, and this works for the hard ones. Okay, we've got a word problem here, and it's got percents in it too. So let's take a look at this one. We're on page 796, number 3. It reads, if 30% of M is 40, what is 15% of M? I chose this problem because usually in school you're taught the whole formula, is over of equals percent. And there's nothing wrong with that. I just was never a big fan of that because I always found it a little confusing. So let me show you another way you can do this problem. Anytime you see the word is, you're going to write an equals. Anytime you see the word of means multiply. Anytime you see the percent sign means 1 over 100. Okay? So let's translate this back piece by piece. 30%. So if 30%, well, we can write 30% as 30 over 100, and you can use your calculator to find out that that's 0.3. So now we have 0.3 of m is 40. So I'm just translating straight across. So what you can do is, if you have your calculator handy, we're going to divide by 0.3, divide by 0.3, that crosses out, 40 divided by 0.3, and you should get m is equal to 133.3 repeating. Alright, so now let's do the second part. It says, what is 15% of m? Anytime you see what, that's your variable. Alright, so I'm just going to say, we'll make it a variable here, we'll make it n. N is 15%. Well, 15% is going to be 15 over 100, or 0.15 of m. Alright, and what did we say m was? We said m was 133.3 repeating. Now if you still have it in your calculator, we're just going to multiply times 0.15, and you get n equals 20. Choice B. So what's really good about this is that you can use is over of equals percent. I just find it easier that anytime you see an is, that means an equal sign. Anytime you see an of, that's a multiplication, or you multiply. And anytime you see percent, you're going to divide by 100. I guess you could call this a calculator trick or a tip. I think most students know about it, but if you don't, it's really helpful. Let's say you're doing a problem and you get, I don't know, you get an answer and it's in decimal form, right? Let's say you got 0.256. But when you look over at your answer choices, all your answers are in fraction form. All you have to do, hit math, hit enter again, you get the fraction function, alright, and it'll convert it into a fraction. Alright, so really helpful if you get a decimal and all your answer choices are in fraction form. We're on page 950, this is number 7, and it's an inverse problem. Let's take a look. If y is inversely proportional to x and y equals 15 when x equals 5, what is the value of y when x equals 25? Alright, so I can show you a formula how to do this. Before I do that, you should understand what the heck inversely proportional means. So what that means is one variable goes up, the other variable has to come down. Okay? So when you get that kind of catchphrase, inversely proportional, you can use this formula. xy equals k, and k is your constant. Okay, it never changes. So let's plug in the values that we have into this first one. So y is 15, tells us x is 5. 5 times 15 equals 75. So k equals 75. Again, that's our constant. So now what we're going to do is we're going to use the equation again, now that we have our constant, and plug in the other values. What is the value of y when x is 25? Well, x is 25. We're trying to figure out what the heck y is. And now we know from before that our k is 75. Divide both sides, and you should get y is equal to 3. Choice C. Okay, so this is a really handy formula to know when you're dealing with inverse problems. Another way you could think about this problem is that x went from 5 to 25, so it went up by a factor of 5. That means that y has to go down by a factor of 5. Okay, so if it's going down by a factor of 5, 15 divided by 5 gives you 3. Again, if that kind of thinking is too hard for you, or it just seems a little too foreign, just use the formula.